All right, you guys, welcome to 7.2. We are going to take what we learned in 7.1 and expand our knowledge to the quadratic. So it's going to be basically the same goal. We need to be able to take information that's given to us and write a quadratic model for it, or an equation that would map what we are seeing. So go ahead and read this first paragraph, or this first sentence right here. Paragraph. Now there's two different forms we might see. The first one's called intercept form because this is going to be the location of your x-intercepts. This is what the form looks like. This x1, x2, those are your x-intercepts. You'll use this form if you know where something starts and you know when something lands. So for example 1, determine the equation of the quadratic given the x-intercepts and a point on the graph. Great. So for this basic form, this is going to be intercept form because that's what we're given. So a times x minus x1, x minus x2. And your x1, x2 values will come from here because those are your x-intercepts. So it doesn't matter which one's x1, which one's x2, you just plug them in. You've got y equals a times x minus your first x-intercept times x minus your second x-intercept, which we could simplify that minus would be a plus. And we're done except for the a value. So if we were to list steps on what to do, the very first thing we do is we need to choose the form, choose the equation. The two you'll have to choose from are intercept form, which is this one, or vertex form. We need to plug in your extra point to find the missing variable that we don't know is a. And then at the very end, we're going to finalize, I guess, or rewrite our equation. Okay, so we have our extra point. This point is 0, 4. We're going to use this. We're going to grab the x value and the y value from that. Everywhere there's a y, we're going to plug in a 4, just like we did last time. Everywhere there's an x, we're going to plug in a 0. Fantastic. And now what we have is an equation with one variable. And if we have an equation with one variable, we can solve that one variable. So here's where we use the mad math skills. 4 equals a times -2 times +2. Be sure to keep all of your math organized. The more organized you are, the less likely you are to make a mistake. It's just part of that development that's essential to be doing upper division math. And then we're going to divide both sides by -4 because it's connected by a multiply. So we want to cancel by using division. So a would be equal to -1, which means now we go back to step 3, finalize, rewrite. We're going to take that -1, come all the way back up here with it. So y equals, you can say -1, you can just say negative. So y equals negative x minus 2, x plus 2. And that is it. Okay, let's look at the next one, next page. Let's do it again, x-intercepts. This time, not a bad idea to just pause the video. Let's see how far you can get. It's okay if you don't get the whole thing. It's only the second example that we're doing, but it's really critical that you guys take a minute and see, like, what can you do on your own without me being there helping you? So I would pause the video, try it, see where you get stuck, and then resume the video. All right, here we go. We are given x-intercept, so we're going to use intercept form again, which is y equals a times x minus x1 times x minus x2, where one of these is x1 and one of those is x2. Plug in what we know. Y equals a times x minus x1 times x minus x2. Now that minus does become a positive. So step 1, plug in everything you know. Step 2, utilize the extra point that we have. Everywhere there's a y, we're going to be plugging in a 4. Everywhere there's an x, we're going to be plugging in a 2. So everywhere there's an x, we plug in a 2. Everywhere there's a y, we plug in a 4. We also had some substitutions going on right here with our x1, x2. All right. Simplify. Now we're going to wrap it up. A times 4 times -2. That's like saying 4 equals a times -8. Now the a and the -8 are connected by multiply. Let's divide both sides by -8. So a is equal to a -1/2. And I'm going to write my answer above because I've ran out of space. Y equals, we're going to take that bugger, come back up here with it. Y equals -1/2 times x plus 2 times x minus 4. Hopefully, if you paused it and tried this on your own like you were asked to, you would have found like, ooh, I did it, I got it. Or you could have said, I mean, there's value in knowing where you're making a mistake. So you could have said, I did it good here, I did good here. This is where I started to make my mistakes. And then when you're about to try the next one, you'll know if you've conquered that mistake or not. So again, pause it before you try part C. Try part C, get as far as you can, and then come back when you're ready, and let's see how you did. Okay, here we go. Plug in what we know. Again, we're given x-intercepts. So y equals a times x minus x1, excuse me, times x minus x2. So we're going to substitute our x-intercepts in for, not there, for the x1, x2. Now we plug in what we know. We want to utilize this extra point right here with your x values, make a substitution, and your y values, make a substitution, so that the only variable we have left is the a variable. So we make that substitution. Now we got to clean it up, figure out what a is. So -3 equals a times -3 times 1. If you want, you can clean that up further. This one's not that hard. Don't treat that as an a minus 3. Treat it like an a times a -3, because that directs what you do next. How do you cancel a multiply? You divide. So a is equal to -1. Which means my final answer, equation, plug that bugger back in right here. You've got y equals -1, which I'm just going to say negative. You could say -1, x minus 6 times x minus 2. Whoop, whoop. What's vertex form look like? Y equals a, same a, x minus h squared plus k, where your h and your k is your vertex. And again, don't forget, x's lie. So now that we've done that, I bet you could pause the video and you could get, between these steps right here and what we've already done in 7.2, my gut says you can pause the video and try this one on your own. The biggest thing is to remember is when you're plugging in what you know, you got a x minus h squared plus k. This is your h, this is your k. If you know the form, it just slips in. You don't have to think too hard about changing the sign. But the biggest thing that students will make a mistake on is if that's a positive one, they put a positive one there, and that's not what we want because we want to flip that sign. So as you're plugging in what you know, x minus 1 squared plus k, k is 6. Okay, pause it, finish it, see if you got this. All right, we plug in what we know. We need to solve for a. We want to utilize this extra point, 2, 4. So everywhere there's a y, let's put a 4. Everywhere there's an x, let's put a 2. And now simplifying this is going to be a little bit different than the one before. It's just a different equation, but we can clean it up. So 4 equals a times 1 squared plus 6. We can do a 2 for on this one, like a 2 for 1. We can subtract the 6, and we can square this at the same time as I rewrite it. So -2 equals a times 1, which that just means a equals -2, right? Because 1 squared is just 1. So my final answer then would be, take that bad boy, put him up here. Final answer, y equals -2 times x minus 1 squared plus 6. Let's do it again. Now vertex form. Remember vertex form, y equals a times x minus h squared plus k. The more I write it, say it, see it, the more I have it memorized. So if you need it, write it down every time. Okay, pause the video, try it. Let's make sure you got this, see how far you can get. Plug in what we know, y equals a. Now notice every time, I could plug in the y's, the x's, the h's, the k's all at the same time, but when you're making that many substitutions at once, it's easier to make a mistake. So I like to substitute the vertex first, take a breath, and then substitute your extra point, but live your best life, do whatever you want. And then k is -8. We'll put that right here. I don't usually put a plus and minus, but I already have the plus there, so we're going to roll with it. I'll probably clean it up a little bit as I rewrite the next line. Our extra point is this -2, -5. We're going to make that substitution for your xy's. So -5 is equal to a times -2. I'm going to call that a plus 4, since that's what a minus would be. And then just a -8. All right, clean it up. Look inside the parentheses. -5 equals a times 2 squared minus 8. And then, again, you can do this in the same line. You can move it, or you can square it and then move it. You can take 2 steps or 1. It doesn't matter to me. I'm going to add the 8 over and call it a 3. And then a times 2 squared would be a times 4. Divide both sides by 4. And a is equal to 3/4 x plus 4 squared minus 8. Not a equals. Goodness gracious. It's supposed to be a y equals. Okay, vertex is 3, -5. Plug in what we know. Y equals a times x minus 3 squared plus k. There we go. Now it passes through this extra 0.7, -3, so take a second, plug that in. 7 minus 3 squared minus 5. And at this point, I'm hoping that you're not like watching the video anymore. I'm hoping that you are, or at least veering away from the video, just doing this on your own, and then every once in a while checking to see if yours matches mine. That's how you know that you're ready to do your homework by yourself, where you can like step away from that video and just go with it. Okay, let's clean this up. Add the 5. So I've got 2 equals A times 16. Divide both sides by 16. So it looks like A would be equal to 1/8. So final answer then would be y equals 1/8 times x plus 4 squared minus 8. Now, these next ones are exactly the same thing, except for it's the application part, because quadratics are found in real life. Anytime you have something going up and going back down, you're going to have a quadratic model. Alex is kicking a field goal. If the ball lands 22 yards away, what is the equation, the path of the ball, maximum, blah, blah, blah. So I start by drawing a picture. Alex is here, kicking a ball, coming back up. It's a great parabola. What do we know? Starts at 0, 0. I'm assuming kicking off the ground, so one of our zeros will be at 0, 0. The ball lands 22 yards away, so that's going to be your next x-intercept. And it reaches its maximum height of 15 yards. That's the maximum value. And the maximum value happens at the vertex. Well, the vertex is halfway between those 2 points, so the x-coordinate would be 11. The y-coordinate would be 15. Now, sometimes you're only going to be given zeros, you have to use that form. Sometimes you're only going to be given the vertex, you have to use that form. In this case, you're given both. So you can choose which form you like better. Personally, going through the math, just eyeballing how many steps that took versus, maybe it's the same, how many steps that took. I don't know, I kind of think intercept form might be the more simplistic form. But, you know, like I said, you do you. It doesn't matter to me. And in fact, it's not hard to transition to the other one. The hardest thing is finding the A value. And once we have the A value, writing it in both forms isn't that hard. So let's use intercept form first. And then next time we have a choice, we'll use vertex form. So intercept form looks like this. Y equals A times x minus x1 times x minus x2, where our x1, x2 are going to come from the starting and ending points. So y equals A times x minus x1 times x minus x2. Where's our extra point going to come from? Right here. We're given the vertex, it's not one of the zeros. We can use that as an extra point. So let's do that. So y, which is 15, equals A times x, which is 11. 11 minus 22. Clean that up. 15 equals A times 11 times negative 11. I just wanted to set you up to expect that we have a 121 in there. Cool. These are connected by a multiply. Let's divide both sides by a negative 121. And A is equal to negative 15 over a 121. Notice I just slipped that negative to the top. Like I mentioned, we don't generally put negatives on the bottom. Maybe that was the last video. I don't know. So here we go. What's our equation? Y equals A 15 over 121 times x minus 0. So I'm just going to leave it as x times x minus 22. That's the intercept form. Just as easily, you could write it in vertex form, though, because now we have the A value. A value is the same regardless of the form you choose. X minus your x part of the vertex plus the y part of your vertex. There's that one. Doesn't matter which form you choose to find your A value, you should be able to fill that in pretty quickly. Next one, May hit softball, so the maximum height is Okay, let's draw the picture. So May's hitting a ball. It's not starting from the ground. She's not golfing, but it's going up, going back down. It's a terrible picture, but we're rolling with it. The maximum height was 60 feet at 3 seconds after she hits it. So this must be time. This must be height. And when it's 3 seconds, the ball's 60 feet in the air. If she hit the ball 3.5 feet above the ground, who chose 3.5? Awesome, that was rude. What is the path the ball takes? Do we have any zeros? We're not getting, I mean, there are some. One's over here in the negative. That doesn't make sense in terms of the problem. One's back here. Don't know when it lands. That's okay. We know the vertex. And we know our extra point is 0, 3.5. So we have to use vertex form. That's the only thing that we're given. Here we go. Vertex form looks like this. Y equals a times x minus h squared plus k. What do we know? Y equals a times x minus h, which is the x part of the vertex, plus the y part of the vertex. Plug in what we know. 3.5 equals a times 0 minus 3 squared, which 0 minus 3 is a negative 3. And negative 3 squared is a 9. Let's subtract 60 from both sides. So I've got a negative 56.5. Divide both sides by 9. Ooh. And we don't really want that to be a fraction. So what I'm going to do, if you have a calculator, do the 56.5 divided by 9, and then use the button that changes it into a fraction. Okay, let's write our equation then. We do need to put it in vertex form. A equals negative 113 over 18. Does it make sense that that a value is negative here? Well, it is an upside down parabola. So yeah, it seems to reason that a should be negative because that's what it looks like when your parabola opens down. Did we get that for part A as well? A was negative, parabola opens down, good. So if you can think of an example of when the parabola would open up, then we would expect an A value to be positive. Okay, next one, Millie is about to zip line through the jungle. The lowest point of the zip line is 30 feet above the jungle floor. She will get there in 2 minutes. The instructor told her to watch when she was at 3-minute mark for a wonderful view. So what's gonna happen? Well, basically, you've got 2 ropes. There might be a slant to it, but whatever. And once she puts weight on the rope, maybe she'll come back up a little bit. It's gonna look something like that. So that is a parabola opening up. We expect A to be positive. Let's have this be like the axis, and that be the jungle floor. So let's read it again. The lowest point of the zip line is 30 feet above the jungle floor. That's going to be the height right here. And she will hit that at the 2-minute mark. So this is minutes. The instructor told her to watch when she was at the 3-minute mark. So right here at 3 minutes for a wonderful view. 3 minutes, she's 50 feet above ground. What is the path of the zip line? So what do we know here? Well, we know that this is the lowest point, which means that's the vertex. And we don't know any of the zeros, which maybe makes sense because we're starting up in the air. It's not crossing the ground at all. Your extra point is 350. So let's use vertex form. Y equals A times x minus h squared plus k. A times x minus 2 squared plus 30. So substitute in the x part and the y part. Or sorry, yeah, of the vertex. Now we're going to utilize our extra point here and here. So 50 equals A times 3 minus 2 squared plus 30. And now we solve. So 50, that's a funny 5, equals A times 1 squared plus 30. Let's subtract the 30. So 20 equals A times 1. So 20 equals A. That seems really skinny. That's okay. Y equals 20 times x minus 2 squared plus 30 would be the equation that maps Millie's travel on the zip line. Why don't you pause it, see how far you can get, draw the picture, and let's see how you do. Come back when you're ready. Last one, Sean is kicking a soccer ball to his dad, and he was 10 meters away. So, ball from the ground, assuming he's not like drop kicking in the air. It was so bad. No, it's not any better. Whatever. One more time. Maybe a little better. So dad's standing here 10 meters away, starting at 0. After 2 meters, which is probably about right here, the ball is 1 meter in the air. So 2, 1 would be that extra point. This must be height. This must be distance. What do we know here? We know the zeros are at 0 and at 10. We don't know the vertex. We know the x part of the vertex. We don't know how high it gets. We could figure out the x part. We're not told it. We know our extra point is at 2, 1. So we have no choice but to use intercept form, which looks like this. Y equals A times x minus x1 times x minus x2. Y equals A, x minus the first 0, and x minus the second 0. Now let's substitute our x and our y. using that extra point. Everywhere there's an X, we're going to plug in a 2. Everywhere there's a Y, we will plug in a 1. And that eliminates all variables except for the A value, and then we can solve for A. So just double check my math really quick. 1 equals A times 2 times a negative 8. So 1 equals A times a negative 16, which means A is equal to a negative 1 over 16. A is negative, that seems to make sense. Final answer, Y equals X minus 0, and then X minus 10.